Hi, so today we're going to be looking at another proof on the Pythagorean theorem. First of all, if you want to see many other proofs on this theorem, just go to the description and you'll find a link to a playlist in which we'll have many proofs on this theorem. So, well, let's just get started with it. First of all, before we prove any theorem, we have to state it, right? We have to know what we're dealing with. So let's consider a right angle triangle with sides A, B, and hypotenuse H. And, well, the Pythagorean theorem tells us that in this kind of triangles, we always have the relation h squared equals a squared plus b squared. Now, in order to prove this result, we're going to be needing some previous results, so let's look at them first. The first result is that the angles of a triangle sum 180 degrees. So in our case, in the case of a right angle triangle, we have alpha, phi, and 90 degrees. So if we sum these three angles, alpha, phi, and then 90 degrees, we get 180 degrees. Now, subtracting 90 degrees from both sides of the equation, we will get the following relation, that is that alpha plus phi equals 90 degrees. So, okay, this is the first result, it's pretty simple. Now let's get on to the second one. The second result deals with the area of a triangle. In general, we have that the area of a triangle is equal to 1/2 times the base times the height. In our case, the base can be considered as b and the height as a, so we'll have that the expression for the area of a right angle triangle is b times a over 2. So this is the second result that we'll need. Now the last result is also pretty simple, it's just the area of a square with side L. So in general, we'll have that the area of a square is the side square, and in our case, it's just L squared. So these three results are all we need really to prove the Pythagorean theorem. So for now, let's just put them aside for a minute and we'll come back to them when we need them. The first step in our proof is to consider the original right angle triangle. Now we will make a copy, rotate it 90 degrees clockwise and place it on the right hand side of this triangle. We will make another copy, rotate it 180 degrees and place it below our previous copy. And lastly, we make yet another copy, rotating 90 degrees counterclockwise and place it below our original triangle on the left hand side of our previous copy. This is the shape that we end up with. Really, the outline of this shape is a square of side h, and it's a square because, well, all the sides are h, and also the angles are 90 degrees because alpha plus phi is 90 degrees. So the inside of our shape is really just a square of side h. Now, notice that there's a smaller square in the middle with sides, well, b minus a, because b is the base of the first triangle and a is the height of the fourth triangle. So L really is nothing but b minus a. So we have a square with sides b minus a. Apart from this, we also have 4 triangles with the same area because all we have done really is just rotating the original triangle. So, as you see, what we have is that the area of the big square, which is nothing but h squared, is equal to the area of the small square, which is b minus a squared, times 4 times the area of a triangle, which is b times a over 2. Expanding the square and simplifying the expression, we have that the 2ba cancels out, and then we are just left with h squared equals a squared plus b squared, which is nothing but the Pythagorean theorem. So as you can see, with this really simple geometry approach, we have proven the Pythagorean theorem. I hope that you enjoyed the video, and if you want to see more animations and explanations on math and physics, just subscribe to the channel and stay tuned. See you in the next video.